So dear student, in this video we are going to continue with our last discussion, that is motion in a magnetic field. In a magnetic field. So what we saw was, if any charged particle has a velocity, if any charged particle has a velocity perpendicular to the magnetic field is going inside, velocity is in the plane of the paper, so velocity is perpendicular to the magnetic field. So if any charged particle is moving perpendicular to the magnetic field, then it will have a circular trajectory of radius r, and the force which drives it to the circular path is your centripetal force, which is mv square by r, which will be nothing but the magnetic force itself, for which the radius of the trajectory will be mv by qb. But now in this discussion, what we will going to do is, suppose you have a magnetic field in this direction. Now suppose you have a charged particle q. Now if the charged particle will have a velocity which will not be perpendicular to the magnetic field. So this is the direction of the magnetic field. Now I have changed the magnetic field direction, like it is not inside the plane of the paper, but rather it is in this direction. So a charged particle has a velocity in a random direction which is not perpendicular to the magnetic field. So in this case, what will happen? So what will happen is, this velocity can be resolved into two velocities, one parallel to the magnetic field and one another perpendicular to the magnetic field. So this random velocity can be resolved into two velocities, one parallel to the magnetic field, one perpendicular to the magnetic field. And we know what will happen if the velocity is perpendicular to the magnetic field. So this perpendicular velocity will make the trajectory a circular trajectory around the magnetic field. So what we saw earlier was, the magnetic field was in this direction. So if the velocity was perpendicular to the magnetic field, the trajectory will be circular, which bound the magnetic field. So similar manner, this velocity is perpendicular to this magnetic field, so it will have a circular trajectory which will bound the magnetic field. And this parallel velocity, see, what will happen if a charged particle is moving parallel to the magnetic field? The force will be qv cross b or qvb sin theta. Now if v is parallel to b, that means theta will be 0 degree, that means force will be 0. So if a charged particle is moving parallel to the magnetic field, it will not experiences any force. That means the parallel velocity will remain parallel forever, but the perpendicular velocity will make the path circular. So what will happen? What will happen is, see, this kind of trajectory. The perpendicular velocity will make the trajectory circular, but the parallel velocity will shift the charged particle along with the magnetic field. So this is magnetic field. The perpendicular velocity, this is a perpendicular velocity. The perpendicular velocity will make the circular path trajectory, but it has also a parallel component of velocity which will drive the charged particle along the magnetic field. So in total it will have a helical trajectory. So the trajectory will be helical, or not helical, it is known as spiral trajectory. Now let me do something more. Now we know linear velocity will be equals to angular velocity into radius of the trajectory. Now since in this case the radius of the trajectory is nothing but it is mv by qb, so put it there, mv by qb, so radius is mv by qb. That means your angular velocity will be vv get cancelled, so angular velocity omega will be qb by m. So this is the angular velocity of the charged particle which is spiraling along the magnetic field. And let us do something more. Now see, when this charged particle makes a complete circular motion, what will happen is it will move towards the x-axis direction by a little bit. When it makes a circular trajectory like this, it will shift towards the parallel x-axis. This way, it was here, now it will reach here. So it will, when it makes a full circular trajectory, so it will shift by this much amount, or it will shift by, in another revolution it will shift by this much amount, in another revolution it will shift by this much amount. So this shift in y direction is known as pitch. This shift in y direction is x direction is known as pitch. While spiraling, it has two kind of motion, one circular and one linear motion. So for one complete circular motion, there will be some linear motion also. It was here, after it will reach here, after it will reach here, because it has also a parallel velocity. So that distance is known as pitch, and pitch will be equals to this velocity, this angular velocity, okay, or this linear velocity into the time period, this time period, the time period for a complete revolution. So your pitch will be nothing but it is parallel velocity because it is moving along x direction into the time period of the one revolution. So pitch will be nothing but v11 2 pi omega, t is nothing but it is omega is 2 pi by t, or t will be 2 pi by omega, so it is 2 pi by omega. So pitch of this particular motion will be v11 2 pi by omega, so 2 pi by omega is your qb by m, so m will be this. So pitch will be your 2 pi m by qb into m. So this is the pitch of that kind of motion. So this is it for today. We are going to do the next video tomorrow. Thank you.